This is the solutions video for Physics Chapter 1, extra practice problems 6 through 10. All right, so number 6 we have a graph. It says, number 6 says, how many times does the car switch directions and during what time intervals is the car moving the slowest? Well, it switches direction every time the slope changes signs. So that occurs at 2 seconds, at 7.5 seconds, and then again at 16 seconds. All right, so 3 times. All right, and so that's part A. Part B of the question is, during what time intervals is the car moving the slowest? Well, it's moving the slowest when the slope is 0. Okay, so that's going to be right at 2 seconds, 7.5 seconds, and then between 13 and 16 seconds. All right, so when slope equals 0. So that's going to be 2 seconds, about 7.5 seconds, and then between 13 and 16 seconds. All right, number 7. What is the instantaneous velocity at 5 seconds? Well, what I'm going to do here is find a couple of easy places to read the graph. And I can read the graph, and 5 has to be included in that interval on the graph. And I'm going to do it between 2 seconds and 5 seconds because it's pretty easy for me to read the y-axis between 2 seconds and 5 seconds. And 5 is included in that. This is pretty much straight line. I know there's a little bump there, but we're not going to worry about that. So the instantaneous velocity is the slope, and that's going to be the change in y over the change in x, or y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So you can try to do it between, let's say 2 and 4 seconds, but it's much harder to read the graph there at the 4-second mark. So that's going to be, when x is 5, y is 2, so 2 meters minus, when x is 5, y is 0, 0 meters minus 2 meters over 5 seconds minus 2 seconds. So that's going to be negative 2/3 meters per second is the instantaneous velocity at 5 seconds. That's equal to the slope. All right, number 8. So in number 8, we're going to flip the page. Look at this graph. So we've got a velocity versus time graph, and the slope measures the acceleration. So over what time intervals is the car speeding up? Well, it's speeding up when velocity and acceleration have the same sign. So between 0 and 2 seconds, acceleration's negative because the slope is negative, but the velocity's positive, so it's not speeding up. However, between 2 seconds and 4 seconds, acceleration's negative and velocity's in the negative region of the graph. So between 2 and 4 seconds, it's speeding up. Acceleration is not speeding up, it's flat. We have a constant velocity there. And then the slope goes positive, so you have positive acceleration but a negative velocity, so that's not speeding up. When we get to 14 seconds, we have a positive acceleration and the velocity is in positive territory on the graph. So 14 to 16.5 seconds. So far it's speeding up between 2 and 4 seconds, and then 14 and 16.5 seconds, And then from 16.5 to 20, acceleration is negative, but velocity is positive, so it's slowing down there. So speeding up, I'm going to go ahead and write this out again. When velocity and acceleration have the same sign. So on our particular graph, that's going to be between 2 and 4 seconds. And you'll definitely have to read these kind of graphs on the test. And between 14 and 16.5 seconds. Okay, number 9 says, during what time interval is the acceleration equal to 0? Well, acceleration equals 0 when the slope is equal to 0. Just a horizontal, flat slope. And that occurs at between 4 and 7 seconds. If you look at the graph. And then also at just about 16.5 seconds, just for a moment. The slope, when it's changing, when acceleration changes signs there. All right, and then finally, number 10, what's the acceleration at 13.5 seconds? So what we need to do is just pick an interval that includes 13.5. That's easy to read the graph. So I'm going to do it between 12 and 14 seconds. All right, that's a nice straight line there. 13.5 is included in the interval. All right, so our slope is going to be y2 minus y1 over x2 minus x1. So our second y value would be at 14 seconds. That's 0. Minus negative 2. That's at 12 seconds. So that's going to be minus negative and be positive 2 meters per second over 2 meters per second, which is 1 meter per second squared. All right, so don't turn the video off yet, because let's do a test review real quick. How do you study for these physics tests? All right, working all these problems, certainly a good way to do it. So this is how I would suggest studying for the Chapter 1 test. First of all, in physics, it's important to read the chapter. The multiple choice and true-false questions are up a level over chemistry. So reading the chapter will really help. Study the review questions. Study the notes. All right, the vocab. Then I would rework. You just worked the extra practice problems, so I would rework the practice problems. Since it's maybe been a few days, try those again. If you're not real sure about the extra practice, you can always rework the extra practice problems as well. And then one thing I want you to make sure to not forget, our practice problems and extra practice problems did not include a relative velocity problems, even though our notes did. So study the relative velocity problems. So study the blue example in the book and the notes. So we did an on your own with relative velocity, and there was a blue example in the book for that. So that's the velocity relative is equal to the velocity of what is being observed minus the velocity of the observer. Okay, we didn't get a practice problem or extra practice problem for that, but you are responsible for that on the test. If you do this, you should do really well. And that's all I have for Chapter 1, so good luck on the test.